Okay, let's get into this. Today we're taking a closer look at the Ercolina TB60 Top Bender machine. We've got the specs, the descriptions.
Right, and our goal here is, just based on this material you shared, what's this machine actually designed for? What do these details really mean if you're looking at its capabilities?
Exactly. We have the technical data, performance claims, all straight from the source. So, where do we start? What kind of machine are we even talking about?
What's interesting is the source calls it out specifically as a rotary drawbender.
Rotary drawbender. Okay.
Yeah, and if you think about that method, rotary drawbending, it's known for really high-quality bends. You see it a lot for things that need to look good, like handrails or maybe furniture parts. It controls the shape really well during the bend.
Gotcha. And it gets specific about what it can bend, right? Sizes.
It does, yeah. The source gives us the key capacities. For mild steel tube, it says 212 inches. Then for pipe, it's 2 inches, schedule 40.
Schedule 40. That's standard pipe thickness, isn't it? What does that tell us, practically?
Precisely. So for that 2-inch size, schedule 40 locks in the wall thickness. It means the capacity isn't just about the outside diameter, it's tied to that specific common pipe wall. Oh, and it also mentions square tube, up to 2 inches.
Okay, so tube, pipe, square. Those numbers give you a pretty immediate feel for the kind of jobs it's aimed at.
Definitely.
It also talks about the bending radius,
Right.
the CLR range.
Right. So the maximum centerline radius, CLR, is listed as 15 inches.
15 inches, that's the distance from the bend die's center to the tube's center line.
Exactly. So 15 inches allows for some pretty wide, gradual bends, but then it also says it can bend down to a CLR of 2D.
2D, what does the D mean there?
D is just the outside diameter of whatever you're bending. So take a 2-inch tube, a 2D bend means a 4-inch centerline radius. Pretty tight.
Ah, okay, so it's got range then. Wide sweeps and relatively tight bends for its size capacity.
That's what the source suggests, yeah.
Okay, now this is where it gets really interesting, I think, the precision stuff, the controls. The source seems to talk quite a bit about that.
It does, and it connects back to that claim of consistent quality. How do they achieve it? Well, the source points to a touch screen for programming the bend angle.
Touchscreen, okay.
And what stands out is that it mentions this system has diagnostics built in, and it's multi-language. Yeah, practical things for a busy shop floor.
Right, easier to use, easier to fix if something goes wrong.
Then there's a digital display to confirm the angle, and this is important. It mentions material springback compensation.
Ah, spring back. That's the annoying bit where the metal wants to unbend slightly after you let go, right? Compensation for that must be huge.
It's absolutely vital for accuracy. If the control can anticipate and correct for that, that's how you get the exact angle you aim for, time after time.
Makes sense.
The source also notes electronic counterbending die positioning. It even says it's monitored for accuracy and repeatability. That suggests really fine control over how the material is supported as it bends.
And thinking about workflow, efficiency, it mentions quick change tooling
Right.
and a foot pedal.
Yep, quick change tooling, multiple radii available, it says, and the foot pedal for hands-free operation. It can even take an optional positioning table from Ercolina.
So features like quick tooling changes, hands-free bending, that seems to line up with their claim about increasing profit, right? Faster cycles.
That would be the logical connection, yes.
Yeah.
Faster setup, faster operation.
Okay, switching gears slightly. What about the structure, the power?
The source gives standard electrical options. 480-volt three-phase is standard, 220-volt three-phase is optional. But there's a really notable line in there. It explicitly states no hydraulic components.
No hydraulic components. That really jumps out. What might that imply just based on the source material emphasizing all the electronic controls alongside it?
Well, yeah, putting those two things together, the focus on electronic monitoring, touchscreens, and the explicit no hydraulics, it suggests the design relies purely on electric or maybe pneumatic systems for movement.
Which could mean
It could suggest things like very precise electronic control, maybe quieter operation than hydraulics often are, perhaps simpler maintenance without hydraulic fluids and seals. But, the source doesn't spill those benefits out. It just highlights the absence of hydraulics.
interesting. And there was one more crucial detail, a caveat almost, about the capacity figures.
Yes, really important. The source is clear. All those capacities, the 212 talent tube, the 240 pipe, they're based on A53 grade A material. That's a specific steel with a 48,000 PS tensile strength.
Okay, so
So it warned you that using heavier wall materials or materials with higher tensile strength will reduce the machine's capacity. You absolutely can't just assume it will bend, say, a much stronger 2-inch tube just because it can bend the A53 grade A.
Right, that makes perfect sense. It gives you the baseline, but you have to check against the material you actually plan to use.
Exactly. Check your material specs.
Okay, so let's quickly recap based just on the source. We're looking at an Ercolina TB60 rotary draw bender. It handles specific sizes of tube, Schedule 40 pipe, and square material. It offers a decent range of bend radii from quite wide down to 2D.
And the big emphasis seems to be on the control system for accuracy touchscreen programming, that crucial spring-back compensation, electronic die positioning, plus features for efficiency like the quick tooling and foot pedal.
Structurally, it's three-phase electric powered and notably has no hydraulics. And always remember that capacity warning about material strength and thickness. Those numbers are based on A53 grade A steel.
And the source ties all this together by claiming it increases profit and improves product quality through consistent, repeatable bends.
Which is usually the goal. Okay, here's something to think about, based only on what the source emphasizes. Given that strong focus on electronic monitoring, the touchscreen controls, and specifically stating no hydraulic components, what unique advantages or operational characteristics might that specific design approach imply for hitting high accuracy and repeatability in bending, maybe compared to machines built differently? Something for you to consider.